Yo, check this out. Do you know that mechanical energy is the sum of kinetic and potential energy?
Wow, that's awesome.
But what is kinetic and potential energy? Listen carefully. Potential energy is the energy stored due to the position of an object. Another way to say this is that potential energy is the stored energy with the potential to do work. But what was kinetic energy? Okay, you stupid. Kinetic energy is the energy due to motion. But this is not over here. They are also conservative and non-conservative forces. A conservative force is a force done in moving a particle from one point to another, such that the force is independent of the path taken by the particle. Some examples of conservative forces are gravity and elastic forces. On the other hand, we have non-conservative forces, which are the ones that work depends on the path taken. An important characteristic is that work done by a non-conservative force adds or removes mechanical energy from a system. Some examples of non-conservative forces are friction or air resistance. Okay, nice, but what is work and energy? What's that? Let me explain you. Energy is the ability to do work, and work is the energy transfer to or from an object via the application of force along a displacement. The law of conservation of energy states that energy can be changed from one form to another, but it cannot be created or destroyed, and that is what we are going to prove in this video. Here we have a bigger and smaller ball above it. Both have the respective potential energy. This energy is going to be transformed into kinetic energy at the time that the two balls fall into the ground. When they touch the ground, the energy is released in form of heat, and the normal force of the ground pushes the balls up following the third law of Newton, and overall this follows the law of conservation of energy. Now it is time to prove this with numbers. So, here we are going to prove the conservation of potential energy. In this case, we are going to take in count the highest point of the ball before touching the ground and the highest point after touching the ground. The reason of this is to make easier the calculations. Those references are 1 meter and 80 centimeters before hitting the ground and 1 meter and 70 centimeters after hitting the ground. As we said before, this is easier because in those positions the velocity of the balls are zero, and because of the balls aren't falling yet, there is no kinetic energy, there is only potential energy. That's why we are going to only use the equations of potential energy, which are mass times gravity times the position of the object. The objective is to obtain the potential energy of the little ball before touching the ground and after touching the ground. And if the result is the same in both positions, conservation of energy is proved. We multiply 0.028 kilograms times the gravity times the height of the objects. We consider 1 meter and 80 centimeters and 1 meter and 70 centimeters. We can see that the results only has a difference of 300ths, and the result was 0.49 joules from the position 1 and 0.46 joules from the position 2. And if we round off these two numbers, we can get that they are the same because they are only 0.5. Actually, this difference in the two results is explainable. All this because some energy was lost at the time that the balls touched the ground. That is also provable with numbers, but if we would do that, this video will last forever. Here we have another video in which a similar situation occurs, and actually here the balls go much upper, which is very interesting. The making of this video and seeing how physics work in real life opened our eyes. And yes, physics works and conservation of energy too. Now we see that physics can explain everything in this world, as well as in the universe. Also, we felt more confident at the time of making the calculations and proving the things because, as you can see, everything is provable with numbers. All is about that: numbers, physics, and nature. Thank you.